Hello everyone, my name is Dr. T. Rajani. I am from the Department of Physics, VJEC JYOTHI Institute of Engineering and Technology. Today I am going to deliver a lecture on the topic of semiconductors. In this semiconductors, I would like to deliver basically the importance of semiconductors, the characteristics of semiconductors, how it is different from the conductors and insulators. So what are semiconductors? Semiconductors are extensively used in every electronic circuits. As its name implies, a semiconductor is a material that conducts current but only partial flow of electric current. And its conductivity always lies between a conductor and an insulator. So basically we know in every motherboard, in every electronic circuit, these kind of semiconductor active and passive elements are always present. They are almost found in all the electronic devices and circuits. The first one is germanium and silicon, germanium, selenium. So like that we use a common semiconductor compounds also we use. Most of these semiconductors resistance always lies that between the conductor and an insulator. If we look at, apart from germanium and silicon, we can look at this kind of a part of a periodic table where the third group and fifth group elements and second group and sixth group elements combinedly also forms as a compound semiconductors, and these which I have highlighted, they work as a conductors, and these which I have highlighted with an yellowish color, they work as an insulators. They work as a semiconductors, and remaining them they work as an insulators ideally. So their resistivity always lies between the conductivity and the insulators. So what are the characteristics of a semiconductor? There are basically 2 to 3 characteristics of there where the semiconductors has got a prior importance more than the conductors and insulators. So the conductor's conductivity or the resistivity lies between 10 power minus 6 to 10 power minus 2, whereas the semiconductors 10 power minus 2 to 10 power 9, and whereas the insulators resistivity is 10 power 14 to 10 power 22. So this is a semiconductor diagram where you can see the resistivity lies in between the conductor and insulator. So here I would like to tell you one thing. Here the semiconductor is there where the resistivity can be changed so that it can behave as a conductor. The resistivity of a semiconductor can also be changed so that it behaves as an insulator. That is the easiness of molding a semiconductor because of its atomic structure, because of its nature. That is there. Now coming to the next important thing, semiconductors have negative temperature coefficient of resistance. For example, if you look at the conductors, as the temperature increases, the conductivity decreases. Because the resistance increases, the collisions between the atoms or molecules or electrons increases, thereby current decreases over here. This is the kinds of conductors. So as the temperature increases right from origin to, as the temperature is increasing on x-axis, the conductivity is slowly decreasing on the other hand. And whereas the semiconductors, when you look at this, as the temperature increases, the conductivity slowly starts increasing. So whereas the insulators, you have to increase the temperature to such a higher level, so that it shows a very small conductivity. In the case of insulators. So that as the temperature increases, conductivity decreases. This is termed as a positive temperature coefficient of resistance, which is defined in the conductors. As the temperature increases, conductivity increases. This is defined as a negative temperature of coefficient of resistance, which is making it different to behave in a different way when compared to conductors and insulators. So this property is called as negative temperature coefficient of resistance. This is one aspect where the semiconductors and conductors are differentiated. So here you can see the differences. Which has a low resistivity, the semiconductor lies between the conductor and insulator. They will not behave as an insulator at any temperature, but the pure form of semiconductor will show the properties of an insulator. And they have positive temperature coefficient of resistance, they have negative temperature coefficient of resistance. The next important property where the semiconductors gain so much of importance is doping. Because if you are looking at a conductors, what happens is there are metallic bonds, there are ionic bonds are present. But whereas in semiconductors, covalent bonds are present. Covalent bonds are very good bonds and they prefer to share. So whatever the element you are adding, they are ready to share. That kind of bonding present in the semiconductors. So what happens is whenever you want to add some kind of impurities, whenever you want to increase the conductivity, whenever you want to prepare some kind of hybrid material, for example, you want to prepare the silicon ferrite, you want to prepare silicon nitride, you want to prepare celerium oxide or any kind of indium nitride. So you want to mix indium and nitrogen, they are ready to mix with each other because of the covalent bonds which are present. They are ready to share the electrons, they are ready to bond with each other. That kind of aspect is present in the case of semiconductors. So doping is a process of adding very small controlled state of impurities or in a very small controlled ratio of impurities into a semiconductors. What happens is this doping controls the resistivity and other properties also gets affected with this. So one of the important aspect of the semiconductor is semiconductor doping, negative temperature coefficient of resistance. Semiconductor can be made to behave as an insulator as well as a conductor with respect to impurities, with respect to temperatures also. Now coming to this one, if you are looking at this as silicon crystals, I have told you that there is a covalent bond. So here you can see the bonds are shared between the electrons. These are sharing their bonds and the electron shells gets filled up completely. So this is the germanium or silicon, this is the covalent bond, this is the bonding of the electrons. You can see any of them, they have 4 valency electrons. The 4 valency electrons are shared with the neighboring 4 valency electrons of the other silicon atom. So at room temperature, what happens is, if you are looking at an energy level diagram, all these valency electrons, these are all valency electrons, right? These are all valency electrons. They are sharing the bonds with the neighboring electrons and they have some kind of energy band. So they form an energy band which is a valency band. So above the valency band, you can see this is a valency shell electrons which are having a band form of energies, So above this valency band, there is another band which is called as a conduction band. Initially, for a semiconductor, this valency band is completely full and this conduction band is completely empty. At this stage, it behaves as an insulator. It shows the properties of an insulator. It is not an insulator. It exhibits the properties of an insulator. So, but when you are giving the temperature, what happens is the electrons are partially moving to the conduction band and the holes are forming in the valency band. So, at any temperature or at above room temperature or a partial, when you are raising the temperature, what happens is a partially filled conduction band, a partially filled valency band can be observed, and the gap between the conduction band and valency band is 1 electron volt. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.